Continuing on with some more of these types of problems. Again, the method is going to be to figure out where we're going to place this decimal so that we have a number between 1 and 10. I'm going to place the decimal right here between the 4 and the 6 because that means I'd have 4.6, and 4.6 is between 1 and 10. So I'll write that number, 4.6205. Now I don't have to write any of the zeros that follow, just all the numbers up until I get just zeros left over. I move the decimal 1, 2, 3, 4, 5, 6, 7 places, so I know it needs a 7. But is it a positive 7 or a negative 7? That's the next question you have to ask yourself. Because you want to make this 4.6205 46 million, we need this to be a positive exponent, so we're multiplying it by a really, really large number so it can become large again. Moving on to the next one, we're going to figure out where we need to place the decimal so that we have a number between 1 and 10. And if I place my decimal right here, I have a number between 1 and 10. It's 3.25 times 10 to some power. I'd be moving this 1, 2, 3, 4, 5 places. So I'll put a 5 here. I still need to decide if this is positive or negative. In this case, I'm deciding that it's negative because this 3, in order to make it really, really small, I would have to multiply by a very small number, and this would be like having that fraction 1 over 100,000. So it would be multiplying by a decimal, which would make it very, very small. In the next problem, the last one here, we're going to say that we're going to put the figure out where we're going to place the decimal so that we have a number between 1 and 10. We're not going to put it here where a lot of people want to put it here because that's 0.9, and that's not even 1. It has to fall between 1 and 10, so the decimal is actually going to fall behind the 9. So we're going to put 9.0, or you could just simply leave it 9 times 10 to some power. Either one of these answers are okay. You can have 9.0 or just 9 times 10 to some power. How many places do we move it? Well, we're moving it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So I have a 9, but I know that it's going to be negative because I need to make this 9 really, really small. So I need to multiply it by a very small number. Continuing on with scientific notation, we're going to talk about how to write it in standard notation. Again, you can memorize this, but I don't recommend you memorizing it. I like you to think about this logically. So if you have a positive exponent, we're going to move our decimal place to the right. The reason why we're doing that is so that we can create a larger number. Okay, because if you have a positive exponent, you're multiplying by a very large number. A negative exponent, you're going to move your decimal to the left. But the reason why you're moving it to the left is because you're creating a smaller number, because a negative exponent is multiplying by a small number. And so we have 10 to the 7th power. So since this is a really, really big number we're multiplying by, we want to make our 3.2 really, really big. So we're going to move it 1, 2, 3, 4, 5, 6, 7 places to the right. So I get 3, 2, 0. I'm filling in all these with zeros. So I end up having 6 zeros here. 1, 2, 3, 4, 5, 6 zeros. On this next problem, I have the exponent of 4. So I know that is a large number. It just happens to be 10,000. So I know I'm going to be multiplying 5.07 times 10,000, which would mean you're moving your decimal to the right because you're making your number larger. So we'll move it 4 places, 1, 2, 3, 4. So that means I have a couple zeros to fill in here. So I have 50700, so 50,700. This last problem, I have a negative exponent, which is saying I'm multiplying by something very small. So I need to make this number smaller, so I'm going to move it 4 places to the left. 1, 2, 3, 4 places. 1, 2, 3 zeros then. So I have 0.00056. These are all written in standard notation now.